Hello, amazing student. This is the Integrated 1 Chapter 3 test review for Standards 3B and 3C. In 2023, we know that our Chapter 3 test will include 3A and 3D as well, so I encourage you to see the old reviews for 3A and 3D. Today, we're going to go over Standard 3B, which is solving these types of equations, and also Standard 3C, which is going to be area models. Of course, you can keep in mind that there is an answer key on the bottom here, so you are welcome to check your work now if you want to work ahead. Otherwise, follow along with the video. So here we go. Solve using the appropriate method. Okay, you can solve these in many different ways, okay, but I'm going to be showing a way that might be preferred by you. So for this first question, I'm going to notice that I have decimals. If I want to get rid of decimals, then all I have to do is multiply by 10 or 100 or 1,000 even. For this case, we only have the tenths place. So I'm going to multiply everything by 10. Everything. That means I'm going to be distributing the 10 into each of these parts on the left side of the equation as well as the right side of the equation. So I'm going to multiply everything by 10. When I multiply by 10, that means I'm going to move the decimal over one place. So that's going to be 33x minus 46 equals 218. I can also encourage you to use your calculators if you are unsure about moving over two decimal places, because that could happen on your test. Then use a calculator. Make sure that you're doing these multiplications correct. Okay? So for this problem right here, we're going to have to solve for x, meaning I'm not going to divide by 33 yet. I need to get rid of what's next to x first. So I'm going to add 46. And whatever I do to one side, I must, that's right, do it to the other side. I'm going to encourage you to also cross things off. Anytime you do an inverse operation, cross it off. And that's going to make your equation even smaller. It's smaller looking. Okay? So that leaves us with 33x equals whatever this is. Now in my calculator I can go ahead and punch this in. 218 plus 46. 218 plus 46 happens to be 264. Dividing both sides by 33 is going to give me my answer for x. Again, crossing it off. 264 divided by 33 happens to be 8. So our final answer for number 1, or the first question, is 8. Let's check our work on the back side. Let's see if we did it correctly. The answer for number 1, or the first problem, is 8. So we got it right. Let's go. Okay, our next question here is going to be a fraction busters question. Now, fraction busters is not the easiest problem, of course, but I'm going to go ahead and look at all the denominators. 3x, 7, and 21. If I can find out what all three of these numbers go into, then I can get rid of the fraction. What do 7, 3x, and 21 all go into? What I'm looking for is the LCD or the LCM, the least common multiple of these three, or the least common denominator. So what do all three of these numbers go into? What's the smallest thing they all go into? So if there's an x, we know there has to be an x. And our final answer should be 21. Do they all go into 21x? Let's see. Yes, they all go into 21x. So that means this is my LCM. Meaning, if I had to do the inverse operations of everything, dividing by 3x, dividing by 7, dividing by 21, what is the opposite of doing all three of those at the same time? You can get rid of all of those by multiplying by 21. But also, if you have x in the denominator, you must also multiply by x. So, in class, we've been showing one of the best ways to show our work here is to remember. Draw these arrows. It reminds you that whatever you do to one term, you have to do to all terms on both sides because of the distributive property. So I'm going to write down 21x 3 times because of the distributive property. Now, in parentheses, I'm going to go ahead and write down each of these terms. So the first term is going to be 2 over 3x. 21 times 2 over 3x. What's the second term? 21 times 1/7. And 21 times, what goes here? Yeah, 5 over 21. Now this is great because this allows me to actually cross things off. It's called fraction busters for a reason. We're going to get rid of all of these fractions all at once. Allow me to zoom in. Okay, take a look at this first multiplication here. What can we cross off? X. We can cross off the x. What about 21 divided by 3? 21 divided by 3 is 7. And what's 7 times 2? 14. Do these multiplications carefully. If there's an x and an x, cross them off. What about this one? 21 and 7. What's 21 divided by 7? 3. But there's still an x there. 3x times 1 is going to be 3x. All right, this last 21x times 5 over 21. What could we cross off? 21 over 21. That crosses off, and we're left with 5. With an x there. Okay, now carefully, we're going to solve this. Notice all these fractions are gone because we did fraction busters. How do we do fraction busters? We have to choose which least common multiple all three of these fractions denominators go into. Okay, that allows us to solve it now. We're going to go ahead and move x to one side by subtracting 3x. 14 equals 5x minus 3x happens to be 2x. Now how do I get x by itself? Very good. Divide by 2, and that gives us our answer. 14 divided by 2. Half of 14 is 7. Check our answers in the back. And we got it right. All right, next up is going to be this type of problem right here. So for this type of problem right here, our goal, please write this down. What's our goal for these type of problems? What's our goal for these types of problems? Look at those bases. That's called the base. This is called the exponent. Our goal is, what is it? Yeah, our goal is to have the same base. Same base. So if this is a 5, then I want that to be a 5. So I'm going to write this right here as 5 to the power of 2x equals 5 to the power of something to the power of 2. Now, 125. Is 125 5 squared, 5 cubed, 5 to the 4th? Is it 5 to the 5th? Which one is it? Because our goal is to have a 5 as a base. So I need to rewrite the 125 with a 5. We could check with our calculators. What is 5 squared? 5, 2, power of 2. That's 25. What about 5 to the power of 3? 125. And let's just check over here again. 5 to the power of 4. Way too big. So 5 to the power of 3 is the one that we need to rewrite this as. So 125 is 5 to the power of 3. Notice all we did is rewrite 125 as 5 to the power of 3. Why did we do that? What was our goal? Our goal was have the same base. Do these two numbers have the same base? Do these two parts of the equation have the same base? The answer is yes, they both have the same base now. Now all we need to do now is multiply. I can add parentheses there since it is a power to a power. So that's going to be 5 to the power of 2x equals 5 to the power of 6. Now good news. Did we reach our goal? Same base? We did. Once we reached our goal for the same base, we can go ahead and cross off the bases. Because if we know the same base is 5, if the bases are the same, then the powers have to be the same. Check this out. 2x equals 6. 5 to the power of 2x equals 5 to the power of 6. Therefore, these exponents have to be the same. Solving for x, dividing by 2, we get the answer of x equals 3. Okay, rewatch this part if you're trying to really understand these questions. I encourage you to rewatch them and practice them because it is not easy until you've practiced it. Okay, so for these types of problems, make sure your goal is to find the same what? Make them the same base. All right, this next question, I'm going to go ahead and solve this one right here with a method that I prefer. I know a lot of people distribute the 4 into both numbers. If you did that, you will get the answer of 4x minus, well, 4 times 7 is 28 equals 20. This is called rewriting. But I'm going to solve it using a different method. So if you did not want to solve it that way, we do have another way. And it might be a little easier, right? So what is this question asking us? 4 times x minus 7. 4 times x minus 7. What is the opposite of multiplication? Multiplication and division. What about the opposite of addition? Subtraction. Right? So if I'm looking at this problem and reading it as it is, 4 times x minus 7, what's the opposite of multiplying by 4? Divide by 4. Now I will only divide both sides by 4 if I know 4 goes into 20. Does 4 go into 20? Yes, it does. So I will cross off the 4's. That leaves us with x minus 7 equals 20 divided by 4 is 5. Now compare this to this. A 2-step problem versus a 1-step problem. I prefer the 1-step problems. Let's add 7 to both sides since the opposite of subtraction is addition. And that's going to give us our answer. X equals 12. 5 plus 7 is 12. All right, now let's go ahead and flip our paper to the back. Once you're ready, we're going to go ahead and flip our paper to the back where it is going to be area models. Now, area models. I'm going to grab a new paper here. Since I used a lot of pen, I'm going to grab a new paper here. All right, area models. Our goal for area models is to be able to multiply correctly. Something that is very easily forgotten and common mistakes on test is to get area models, you must multiply. So if you notice there's +4 and +7, it doesn't mean that 7 plus 4 is going to be 11. That's a common mistake. It's not adding, it's multiplying. Our second most common mistake is going to be this one right here. If it's x times x, what is x times x? X times x is a higher power of x. So keep that in mind for these problems. It is a very common mistake when it comes to these tests. So let's begin. For this first one, it is already done for us. So the area model is already done for us, which is good because it's a reminder of how to do area models if you're stuck. So compare these and you can see exactly how an area model works. So for the area sum, it's just going to be adding up all 4 of these terms together. The only thing is we're going to add the like terms. So 12x and 7x, if you draw an arrow from here to here, a little line segment like that, I know that means you just added those together. So adding all of these together, the area sum will be 3x squared plus, what is that? 19? Yeah, 19x plus 28. Now the area product is just going to be length times width. So length times width could be this times this. Otherwise it could be width times length. The order doesn't matter. So I'm going to go ahead and write down x plus 4 since it says x plus 4. And the width would be 3x plus 7. And that's your answer. You can box your answers if you'd like. Now, one thing to keep in mind, product, we remember product does mean multiply. So we are seeing length times width in parentheses like this. Parentheses is required, while the word sum means you're just adding up all the terms inside. Okay, so that brings us to this question right here, the second question here. I guess we can call it number 2. So 7x times x, we're going to multiply this times this. That's going to be 7x squared. 6 times 7x, that happens to be 42x. Just notice we're only multiplying where these two cross. Multiplying where these two cross is going to give us negative 3x. And multiplying where these two cross, right there, is going to give us negative 18. So I'm going to look at the diagonals. Is there anything I can add together? We got these two I can add together. And that's going to give us our answer very quickly. So we get 7 squared when we add up all these terms together. Gives us 7x squared plus 42x minus 3x. That's going to be 39x. And then there's going to be a minus 18 at the end right there. Now the area product is just going to be length times width. This time I can use a little bit of highlighting. Length times width is going to be, just write x first, x plus 6 times 7x minus 3. And that one's done. Okay, next problem here, we're going to move down to the one with the algebra tiles. So algebra tiles, we can add these 1 tiles and label them as 1, kind of like a dice. And we have to label the sides. So the sides of an algebra tile are going to be x and 1, because x times 1 is x. 1 times 1 is 1. 1 times x is x, and x times x is x squared. That's the way to confirm. I do want to encourage you, remember, if it is a small side, do not hesitate. If it's a small side, very small side like this, it's very likely just going to be a length of 1. What's the total area of everything inside of here? Add them all up. Adding the like terms, we're going to get x squared There's only one x squared tile here. Perhaps there might be 2 or 3. It's possible, but in this case we only have 1. How many x tiles do we have? Count carefully. 1, 2, 3, 4, 5. So 5 x's. And then there's 6 1 tiles. Okay, same thing as before. The area product is going to be length times width. So how long is this length right here? It's x plus 2 times, how long is it over here? X plus 3. And that gives us the answer. Nicely done if you got that one right. And we're going to move on to the most difficult question on the page, which is this one right here. Remember, this one is actually like a puzzle. You need to figure out the missing pieces until you have the entire thing filled. So that's going to be, what times negative 4 is 8x? Or you can divide. What's 8x divided by negative 4? I'll say that again. What times negative 4 is 8x? A negative times a negative is a positive. Now what is negative 4 times 3y? Negative 12y. Now we're going to need this piece right here. Using these two right here. 3y times what is 15y? I'll say it correctly. I did say it incorrectly. 3y times what is 15xy? So there has to be an x here. And it's going to be 5 times 3 is 15, so that would be 5x. Now finally we can multiply these two to get this piece right here. What is 5x times negative 2x? Don't add them, multiply. 5x times negative 2x is negative 10x squared. Okay, so that's going to finish up this problem. We're going to add them all up to get our area sum and multiply to get our area product. So our final answer here, I need to write this in pencil this time because it is a longer question, a longer sum. There's no like terms here, so I have to just add them all up. Negative 10x squared plus 15xy plus 8x minus 12y. All of these terms cannot be added together. And finally, length times width is the product. So you can write it in any order. That would be 5x minus 4, shown there. And this one was weird. It did have a negative here, but it's going to be negative 2x plus 3y. I hope that you found this review helpful. Good luck on your test. Remember to also study standards 3A and 3D to prepare fully for this test. If you have any questions, please ask, and good luck.